Welcome to this video on the Automic Automation Azure Logic Apps integration solution. In this video, we will explain the Azure Logic Apps integration and what it brings to the Automic Automation user community. Azure Logic Apps simplifies the way that you connect legacy, modern, and cutting-edge systems across cloud, on-premises, and hybrid environments, and provides low-code, no-code tools for you to develop highly scalable integration solutions for your enterprise and business-to-business B2B scenarios. Integrating Automic Automation with Azure Logic Apps allows you to run workflows in your Logic Apps workspace from Automic Automation. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the configuration of the agent and the design of the two core object templates, connections, and jobs. Finally, we'll run through a demo. Automic Automation plays a central role in orchestrating operations across multiple environments, including the cloud. Automic Automation synchronizes these processes with other non-cloud operations. By integrating Azure Logic Apps, we can configure process automation centrally in Automic Automation and then trigger, monitor, and supervise everything in one place. Azure Logic Apps processes can then be synchronized with all other environments routinely supported by Automic Automation. Azure Logic Apps' role is reduced to execute the jobs. All other functions, especially those pertaining to automation, are delegated to Automic Automation. This means that we don't have to log into the Azure Logic Apps environment and keep on refreshing it by ourselves. Automic Automation manages all the execution and monitoring aspects. The Automic Automation integration provides a simplified view to run workflow jobs. Automic Automation lets us build configurations with intuitive interfaces like drag-and-drop workflows and supervise processes in simple dashboard tools designed natively for operations. Statuses are color-coded, and retrieving logs is done with a basic right-click. From an operations perspective, Automic Automation highly simplifies the configuration and orchestration of Azure Logic Apps jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workload. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workload. A conventional architecture involves two systems, the Automic Automation host and a dedicated system for the agent. The agent is configured with a simple INI file containing standard values: system, agent name, connection, and TLS. When we start the agent, it connects to the engine and it adds two new objects to the repository: a connection object to store the Azure Logic Apps endpoint and login data, and a job template designed to trigger run workflow jobs. Let's assume we're automating for 4 instances of Azure Logic Apps. We create a connection object in Automic Automation for each instance by duplicating the con template for each of these instances. Lastly, we create the run workflow jobs in Automic Automation for each corresponding process in Azure Logic Apps. The Automic Automation jobs include the connection object based on the target system. When we execute the jobs in Automic Automation, it triggers the corresponding process in Azure Logic Apps. We're able to retrieve the successive statuses, supervise the child processes in the cloud, and finally generate a job report. In Automic Automation, this job can be incorporated in workflows and integrated with other non-cloud processes. The procedure to deploy the Azure Logic Apps integration is as follows. First, we download the integration package from Marketplace. This package contains all the necessary elements. We unzip this package, which produces a directory containing the agent, the INI configuration files, and several other items, like the start command. We use the appropriate INI file for our specific platform. Azure Logic Apps is a standard Automic agent. It requires at least 4 values to be updated: agent name, Automic system, JCP connection and TLS port, and finally TLS certificate. When the agent is configured, we start it. New object templates are deployed. We create a connection to every Azure Logic Apps instance we need to support. For this, we use the template con object, which we duplicate as many times as we need. The con object references the Azure Logic Apps endpoint. Finally, we use the Azure Logic Apps template job to create the jobs we need. We match these Automic Automation jobs to the Azure Logic Apps Run workflow jobs. Reference the connection object and run it. We're able to supervise the jobs and their children, generate logs, and retrieve the statuses. The jobs can then be incorporated into non-cloud workflows. We install, configure, and start an agent to deploy the Azure Logic Apps integration. The agent is included in the Azure Logic Apps package, which we download from Marketplace. We unzip the package, which creates a file system, agents/logicapps/bin, that contains the agent files. Based on the platform, we rename the agent configuration file ucxjcidx and set a minimum of 4 values: the agent name, the AE system name, the host name and port connection to the automation engine's JCP, and finally the directory containing the TLS certificate. Finally, we start the agent by invoking the JR file via the Java command. The agent connects to AE and deploys the object templates needed to support the integration, the con or connection object, and the Azure Logic Apps Run workflow job. In our demo, we will create a connection object. Once we have established the connection to the Azure Logic Apps environment, we'll create a Run workflow job. Finally, we'll execute and supervise the job. Let's start with the demo. Here, you see our Azure Logic Apps environment. We have set up a workflow which we have already executed. If we go here, we see that it is a straightforward workflow that makes requests to some URLs. The code fetches data through a simple GET request from a specific URL. Next, we'll proceed to publish the status code we've obtained. Let's move on to the Automic system. Here, we create a connection object with specific inputs to be able to connect to Azure Logic Apps. We must enter the endpoint. This is the URL of the Azure Logic Apps environment. We must then specify an authentication type. We have 3 options: the service principal type, the OAuth2 token type, and the token from file type. With the service principal type, you must define your Azure AD URL, a tenant ID, a client ID, and client secret. With the OAuth2 authentication method, and depending on the version of the OAuth2 authentication method you select, you must either define the resource or the scope. The OAuth2 token authentication type requires you to specify a token, which is a bearer token used to log into the Azure Logic Apps environment. The third type is the token from file authentication type, which requires you to specify the file in which the token is stored. Once the connection object is defined, you can create a Run workflow job. Start by selecting the connection object we have just created. Next, choose the workflow name using the picker functionality. If the agent is not running, you can still provide the workflow name manually or utilize the picker functionality. This feature calls the Azure Logic Apps REST API to fetch all workloads defined for a given tenant ID and client ID, allowing users to select from the options. Then provide one of the 3 payload types. If you do not want to pass any workflow parameters to Azure Logic Apps, select None. For JSON payloads, you can copy and paste JSON content. For this demo, we have selected the file path type and defined the path to the JSON file containing the attributes that you want to pass to the application. Now execute the job. The executions list shows that the job has run successfully. The remote status field in the details panel tracks the status of the job in the target environment. You can see that the execution was successful. The details panel also shows an object variable called and workflow run ID hashtag, which is the job's workflow ID for publishing purposes. It helps you to clearly identify the specific job execution. The report captures the information that the target system sends to Automic Automation when the job has been executed. It contains all relevant information about the job execution and its results. You can see the JSON and the ID we received after executing the workflow. The report provides this information in a format that can be easily parsed for further processing, JSON, XML, and so on. The agent log is an additional report type that captures everything that has to do with the job execution from the Automic Automation perspective. It lists all the parameters that were used to run the job. It also contains the response received from the target system, but in a format that cannot be parsed for further processing. In our case, we see that the execution was successful. Thank you for watching this video.